All right, let's continue on with our discussion of angle relationships. Yesterday, we learned that when you have a pair of intersecting lines like you see here, that there are a couple different angle relationships that are formed. One of those angle relationships is vertical angles. Vertical angles, as seen over here in the left, would be marked by the same letter. So the pair of X angles are vertical angles, and the pair of O angles are vertical angles. They only share one vertex, just one point in the beginning. So they are opposite of each other. It's like they're mirror images. It's like you're looking in a mirror at each other. I call them kissing angles because they meet at just one point, like kissing lips. And those two angles, because they're mirror images of each other, they're congruent, meaning that they are mathematically equal in size. So the pair of X angles are the same size. They're both acute angles of the same measure. And the two O angles are both obtuse angles of the same measure. Also, when you have a pair of intersecting lines, you get what is called adjacent angles. In our figure here, the adjacent angles would be marked by different letters. So any XO pair here would be a pair of adjacent angles. They share a side and a vertex. So not only do they share that point in the middle, but they would also share a side. So if I highlight this particular side here, you can see that this O and this X, those two angles form a pair of adjacent angles. And when you have only two intersecting lines like we do here, those adjacent angles together add up to 180 degrees. But that's only if you have just two intersecting lines. Do the adjacent angles form 180 degrees? And by the way, it's any two adjacent angles. So not only those two, but any two. So I could pick this X and this O, and those two angles would also form a 180 degree pair of angles as they form this straight line when put together. So vertical angles and adjacent angles. But today we're going to look at a couple different other angle relationships that are not necessarily just formed from intersecting lines. They can be formed by just having a pair of angles. So you see here complementary. Two angles are complementary if the sum of their measures is 90 degrees. So you have a pair of adjacent angles here. They're adjacent, I know they are, because they share this side. They share that ray together. So angles 1 and 2 are together adjacent, but we would also call them complementary because together they form a 90-degree angle. They form a 90-degree angle. And you can see over here where it says symbols that it has M angle 1 plus M angle 2 equals 90 degrees. Well, down here where the words are, it says that M1 means the measure of angle 1. So what we're saying here is the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So complementary angles, two angles whose measures together add up to 90 degrees. Also, there is another relationship formed by two angles that is supplementary. Supplementary means that the sum of the two angles adds up to 180 degrees. We saw this with our intersecting lines and adjacent angles yesterday, that two angles formed by intersecting lines that are adjacent add up to 180 degrees. Well, they don't just have to be formed by intersecting lines. You can see here that these two angles are adjacent because they share a side, and they also form this straight line, meaning that their two measures add up to 180 degrees. So we can say the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Supplementary angles are two angles whose measures added together will equal 180 degrees. So Let's take a look at some examples and see if we can identify what kind of angle relationships we have. Look here at example 1. It says identify each pair of angles as either complementary or supplementary or neither. Well, angle 1 and angle 2. Based on what we learned yesterday, when you have a pair of intersecting lines, the relationship that is formed by two angles that are right next to each other sharing a side would be adjacent. So you could say angle 1 and angle 2 are adjacent. But you could also say that when I put those two angles together, they form this straight line, meaning that their measures together would be 180 degrees. So you would also say that they are supplementary. Take a look at example number 2. Now you can see that these two angles here, they're not adjacent. They're not touching each other. They're two separate angles. But you can see that one of them is 60 degrees. And you can see that another is 30 degrees. So if I take them and I add them together, 60 degrees plus 30 degrees equals 90 degrees. And we learned up above on page 544 that two angles that add together to equal 90 degrees are considered complementary. So they are complementary angles, C-O-M-P-L-E-M-E-N-T-A-R-Y. So add the two angles together, get 90 degrees, makes them complementary. Go ahead and take a look at letters A and B and see if you can determine the relationship that these angles have. Let's go ahead and use this information to find the measures of missing variables and missing angles. Here in example 3, it says, find the value of x. Well, since the two angles here at the right form a 90-degree angle as marked by this red box, then we know that they are complementary. That means the measure of one angle plus the measure of the other angle has to add up to 90 degrees. We can use that to form an equation. So the measure of angle CBD is 2x, where the measure of angle ABC is 28. If I add those two measurements together, they should add up to the 90-degree angle that is formed by putting them together. Now all I need to do is to solve that equation. I subtract 28 from both sides of my equation. The 28 and the negative 28 will cross off. 90 minus 28 is 62. So 2x equals 62. I will then divide both sides by 2 to isolate my variable x. 2 divided by 2 equals 1, so I'm left with x on the left, and 62 divided by 2 equals 31. So in my figure, x is equal to 31. Look at example number 4. These two angles, although they are not touching, you can see that the space between them is actually staying the same. It is very consistent and not changing. Therefore, we could tell if we slide those two angles together that they would be two adjacent angles that would form a straight line. In other words, these two angles are supplementary. Their angles together have to add up to 180 degrees. So I can again write an equation. The measure of the one angle, that is 3x degrees, plus the measure of the second angle, which is 123 degrees, together have to add up to 180 degrees. I can then solve that equation by subtracting 123 from both sides. Positive 123 and negative 123 cross off, leaving me with 3x. Drop my equal sign, and 180 minus 23 equals 52. 7. I can then divide both sides by 3 to isolate my variable x. 3 divided by 3 equals 1, leaving me with just 1x, equals 57 divided by 3. 57 divided by 3 is equal to 19. So in this figure, x is equal to 19. That will allow you to do letter C, except probably are looking at letter C going, where are the numbers? Well, there are none. So let me talk to you about this just a little bit. This red box means that that angle formed right there is equal to 90 degrees. It is a right angle. That means the remaining two angles equal 90 degrees, because the whole thing forms a straight line, which has to be equal to 180 degrees. So how could you write x and x together equals 90 degrees? Think about it and see if you can do letter C. Take a look at example 5. It says the picture shows support braces for a gate. Find the value of x. So looking over here at the left, you can see that the gate has a pair of basically intersecting lines here in the middle, and that we have an 80-degree angle and another angle marked by 10x degrees. Since those two angles are sharing a side, those angles are adjacent. And we learned yesterday and today that when you have just a pair of intersecting lines, those adjacent angles also add up to 180 degrees. In other words, those two adjacent angles are supplementary. They have a relationship that adds up to 180 degrees. So I can write that as an equation where 10x degrees plus 80 degrees has to equal 180 degrees because they are supplementary. I would subtract 80 from both sides of the equation, meaning that 10x has to equal 100 degrees. I divide both sides by 10 to get x alone. And when I do that, I find out that x is equal to 10. That should allow you to do letter D on your own. And when you get done with that, that will bring us up to the guided practice on page 546. And we will get together and go over the letter problem.